So in this video, I'm going to discuss about work energy theorem. So it is defined as net work done by the force on the object is equal to change in kinetic energy. Okay. So let us see. This is the horizontal surface and there is an object of mass m which is placed on the horizontal surface, and initially this object is moving with some initial velocity u. Okay. Now I'm applying some external force. So whenever force is acting on this object, automatically the initial velocity of the object changes to final velocity v. At the same time, because of the motion of the object, it covers some displacement and it acquires some acceleration also, right? So already I wrote here, u is called initial velocity, v is called final velocity, a means acceleration, and s bar is called displacement. Okay. Now based on these four quantities v, u, a, s, we know that the third equation of motion, that is v square minus u square is equal to 2as, right? So from this, bring a left side, a is equal to v square minus u square by 2s. Okay, so this is the acceleration which is developed when the object moves from one place to another place. Now coming to here, I applied some external force, right? So force is acting, mass also present, acceleration also developed. So from Newton's second law, force is equal to mass into acceleration, right? So F is equal to m into acceleration formula we know, v square minus u square by 2s. So I'm going to substitute here v square minus u square by 2s, right? So that means this is the force I applied here on this object, right? So according to work done, force into displacement is called work done, right? So the net work done, W is equal to the product of force into displacement, right? So W is equal to force formula we know, that is m into v square minus u square by 2s into, again here displacement will be there, right? So displacement s. So numerator displacement and denominator displacement cut. So work done is equal to m into v square minus u square by 2. So this term we can write it as mv square minus mu square by 2. mv square minus mu square by 2, or we can write it as half mv square minus half mu square, right? So this is the net work done. Okay, but in previous class we discussed, according to kinetic energy, Ke is equal to half me square or half mu square, right? So same thing here, this work done is nothing but in the form of final kinetic energy minus initial kinetic energy. So we can write it as, so half mv square is called final kinetic energy minus half mu square is called initial kinetic energy. Okay, so work done is equal to final kinetic energy minus initial kinetic energy. This final kinetic energy minus initial kinetic energy is called change in kinetic energy. So we can write it as work done is equal to change in kinetic energy. Okay, thank you so much.